In these last few examples, we're going to complicate it just a little bit more and have several situations where we're applying several rules for exponents. And we just have to, again, there's just not one way of doing these. We can do them in a multitude of different ways. I guess I shouldn't say multitude, but several different ways. You just have to decide which method makes the most sense for you. So in example 3A and B, I give you two quantities that in A we're multiplying them and in B we're dividing them. So when we're looking at A here, we know that this is just all multiplication. And in fact, the parentheses here are not even necessary because there are no exponents outside. So this is just a matter of taking 3 times 4, taking x squared times x to the negative 3, and taking y to the negative 4 times y to the 1. Remember, that has a 1. So 3 times 4 is 12. X to the 2 times x to the negative 3 is x to the 2 plus negative 3. And y to the negative 4 times y to the 1 is y to the negative 4 plus 1. So we end up with 12, x to the negative 1, y to the negative 3. Now, please note, the 12 does not have a negative exponent. It does not move. If that were 12x quantity to the negative 1, then it would move with the x, but there are no parentheses around the 12x. So we move only those parts of the expression that have a negative exponent. They are, in this case, the x, so the x will move, and the y, so the y will move. So when I move the x from the top to the bottom, it's going to become x to the positive 1. When I move the y from the top to the bottom, it's going to become y to the positive 3. I just leave the 12 on top. And the biggest mistake I see students make with this is they want to move the coefficient. No, only if it is grouped with that variable and both the coefficient and the variable are contained within the parentheses with a negative exponent outside. So in B, same logic, only we're dividing. And when we divide, we subtract our exponents. But of course, we just divide our coefficients. So we have to divide 12 by negative 3. That's, of course, negative 4. A to the 3 divided by a to the negative 1 is a to the 3 minus negative 1. And b to the 2 divided by b to the 5 is b to the 2 minus 5 power. So 3 minus negative 1 is actually 3 plus 1. So we get negative 4, a to the 4. But 2 minus 5 for our b is actually b to the negative 3. There is only one term, or one part of this term that has a negative exponent, and it is only the b. So only the b will move from the top to the bottom. B to the negative 3 is going to become b to the positive 3 on bottom. We just leave the negative 4a to the 4th where it is. I could have left the negative up there on top as well, but generally I'm in the habit of putting the negative out in front. But either is acceptable. We just don't like to leave that negative in the denominator. Okay. The last kind of example, no, don't chew. The last kind of example that I want to go through with you is one like this one. I don't know why this, I think it's because Clarence is jumping around. My phone is plugged into my computer. Where we're adding two terms that have different bases. So we can't just do anything with their exponents. We have to simplify each piece by itself. So we're adding 2 to the negative 3 to 3 to the negative 1. Well, 2 to the negative 3, obviously it has a negative exponent, so it's going to become 1 over 2 to the positive 3. And 3 to the negative 1 is going to become 1 over 3 to the positive 1. That's what you've got to do first when these bases are not the same. Well, 1 over 2 times 2 times 2 is an eighth. And so we're adding an eighth to a third. And now we just need to remember our rules for adding and subtracting. We need common denominators. 8 and 3 both divide into 24. So we have to multiply the top and bottom of the first fraction by 3 and the top and bottom of the second fraction by 8. So we get 3/24 and 8/24. Now they can be added, and our final answer would be 11/24. Let me know if you have any questions.